Hi everyone. In this video I will discuss about the questions and answers of organic chemistry that came in paper 2 of IIT JEE examination 2010. In our first problem, a reaction scheme is given here where we have a starting material, an amide. Along with that we have two reagents. The first step is the reaction of sodium hydroxide and bromine, and the second step is the reaction of benzoyl chloride. Now you have to remember something, that whenever this kind of amide is present and a sodium hydroxide along with bromine is given as a reagent, then it is a Hofmann degradation. So the steps of Hofmann degradation is given here. Here you can see that for the simplicity of the problem I have written R, not this whole group. So RCONH2 is the starting material. First of all, we have sodium hydroxide, which is a base, so OH minus is going to react. It is going to take away one proton from here. So now you have the negative charge, which may stay in resonance with this carbonyl oxygen, and it will react. This nitrogen is going to react with the bromine this way. So you have this compound. The base will act again. It will take another proton which is left in this nitrogen. So now again another negative charge. So this negative charge will again move due to resonance. But now what will happen in this step? The oxygen, the charge over the oxygen will come back, and this R group will migrate. There will be a migration of this R group from carbon to nitrogen, along with the removal of the bromide as a leaving group. So RNCO will form. This is called isocyanate. So isocyanate will form, and this isocyanate will take on one molecule of water. So here it is. So it will add up. This water will add up in this way. Let me just erase this circle so that it will be easier to explain. Yes. Now you can see that this H, first this lone pair of oxygen, think about this lone pair of oxygen, as this carbon has a kind of positive charge, a partial positive charge, because it is connected with two relatively negative atoms like oxygen and nitrogen, so it will have some positive charge. So this electron pair will attack this electrophilic center, and this H will be taken by the nitrogen. So you will have something like this, where the nitrogen takes the hydrogen from the water and the OH is taken by the carbon. Now what will happen? Now this OH bond will break and carbon dioxide will be removed from the system. So OH bond will break, and this NC bond, the electron, will be taken by the nitrogen, which eventually will take another proton from water to form the RNH2, which is an amine. So from the beginning, if you check, there is a degradation. That means one carbon atom is lost during this whole procedure as carbon dioxide. So we have started with RCONH2 and we have ended as RNH2. So this is a degradation. Now we have the RNH2 and we have our second reagent here, that is PHCOCl. So it will react with RNH2 in our second step, which is a kind of nucleophilic substitution reaction, where this lone pair of nitrogen is going to attack this electrophilic carbonyl carbon. And of course the chlorine or the chloride will leave as a leaving group. This is a good leaving group, so chloride will leave and will give us this compound. So if I now write it down, it is something this. So our product, our desired product, will look like this. Now I have written. So we have to check now that which one matches the structure of our desired product. We have to check the options now. Now if you check thoroughly, you can see that option C is having the structure of the product that we have obtained through this mechanism. So Option C is the correct answer.
In our next problem, three substrates are given and it is asked that they will be separately subjected to nitration reaction using HNO3 and H2SO4 and we have to guess the product. Now nitration reaction is an electrophilic substitution reaction in benzene ring. So it depends on what are the substituent is present in that benzene ring. So if there is a electron donating substituent present like this, so electron donor ED, what it will do, it will increase the electronic charge in this position. So minus delta ortho position and para position minus delta and this ortho position minus delta. And if there is an electron withdrawer present, then the system will be a little bit different. In this case, the electron density will be a little bit high in the meta positions. So when there is an electron withdrawer present in the system, then a nitration will happen in meta position, and if an electron donor is attached with the benzene ring, then the nitration or any kind of electrophilic substitution reaction will occur in ortho or para position. That is the normal rule. Now we have to check our substrate. So if you look towards P had an OH group which is an electron donor, and it also has an electron withdrawer here as a carboxylic acid group. Okay, now we know that when there is electron donor, it will increase the charge density, negative charge density, to its ortho or para. As para is blocked in this case, so we will only look for the ortho position. So here we have a negative charge density, and it also has an electron withdrawer, and we know that electron withdrawal will increase the electronic charge, negative charge in meta position. So this one is also a meta position. So both the group, that means the OH and carboxylic acid group, is actually increasing the electron density here in this position. So nitration will happen here. So if I subject this molecule to nitration, we will get a product like this: carboxylic acid, OH, NO2. Fine. Now our next substrate, that is substrate Q. Now Q has OCH3, which is an electron donor, and also CH3, which is a kind of weak electron donor, weak compared to OCH3. As OCH3 is much more stronger electron donor, so the nitration will be governed by OCH3. That means we have to look for position relative to OCH3. So OCH3 as an electron donor will increase the electron density to its ortho and para position. In this case also para position is blocked by the CH3 group, so we will only check the two orthos. So any one of the ortho will undergo nitration. So our nitro substituent will be like this: OCH3, CH3, NO2. In the third case, that is PQ and S, what will happen here? We have, look at this problem. We have a benzene ring here which is connected with an electron withdrawer, because there is a carbonyl carbon here which withdraws the electron. So the electron charge density will be in the meta position relative to this carbonyl group. That means either this or this will have higher negative charge density, whereas here we have a kind of electron donor which will increase the electron charge density in ortho and para positions. So what will be the answer? Because in this case electron donor is much more stronger, I will say, like it will actually guide the nitration because it increases the electron density in the ring, whereas electron withdrawer actually withdraws the electron from the ring. So nitration, which is an electrophilic substitution reaction, that means electrophile will attack? Something which likes to attack a center which is filled with electron. So NO2 is such kind of a reagent, NO2 plus is such kind of a reagent which likes a center which is filled with electron, because it is an electrophile, it loves electrons. So it will always attack a ring which has higher electronic charge density. So it will try to attack a benzene ring which is connected to an electron donor, not with an electron withdrawer. So the nitration will occur to this ring which is connected with oxygen directly. So our product will be like this, and yeah, so this will be the product here. So NO2. So this is our third product. So now we have to choose our option. Now if we look at our option, we can see that only option C is matching with our predicted products. So C is the correct answer for this question. Our next problem is a very important kind of problem, because in this kind of problem, if you get the solution, you can answer at least 3 questions. So like here it is written that paragraph for questions 12 to 14. That means if you can get the solution of this problem, you can easily answer 3 questions. So what is the problem? It is written here that 2 aliphatic aldehydes P and Q react in the presence of aqueous K2CO3, that means a base, to give compound R, which upon treatment with HCN provides compound S. On acidification and heating, S gives the product shown below. Now this is the product. Now whenever there is a formation of cyclic ester upon acidification and heating of a compound, then that compound must contain a hydroxide group and an carboxylic acid group which has undergone a kind of intramolecular esterification reaction. So this is the cyclic compound we have obtained after the reaction of another compound which must have a carboxylic acid group and a hydroxide group, and this carboxylic acid group and the hydroxide group has gone through an intramolecular esterification reaction to give you this cyclic ester, and that happens because of the environment, that acidic and heating environment. But this carboxylic acid also form a nitrile group which was there in S. So this acid and heating that you have provided to S has converted the S, that is the nitrile group of S, to this carboxylic acid group first, and then there was the intramolecular esterification reaction. That means in S we have the nitrile group. How do you know that S have the nitrile group? Because S is something which is synthesized due to the treatment of HCN. That means there should be the nitrile group in S, and S has undergone a hydrolysis in presence of acid first to give you this carboxylic acid group, then the esterification step. So when you have added H plus and you have applied some heat to this, then this nitrile group first got converted to carboxylic acid, then an intramolecular esterification reaction to give you the final product. Okay, now where did S came from? So S came from a treatment of HCN to another compound R. Now Cn minus is a very well known nucleophile, and it must have been added to an electrophilic center. So this OH group must be a must be a carbonyl group or carbonyl oxygen in compound R. So this cyanide which has been added to R is a nucleophile which attack this electrophilic center to give you this compound S. And now we have the structure of the R like this, and from the question we can see that R is formed due to the reaction between P and Q, which are aldehydes in presence of a base. So two aldehydes reacting in presence of a base, this happens in either aldol condensation reaction or Cannizzaro reaction. But as we are getting a single product R, that means it must be aldol condensation reaction, not Cannizzaro reaction. Now in aldol condensation reaction, we know that the carbonyl carbon of the less crowded aldehyde is converted to the secondary alcohol or primary alcohol, depending on the carbonyl carbon. So here we can see a hydroxide group here attached with this carbon, which is a primary hydroxide group. That means this carbon must be the least hindered or least crowded carbonyl carbon in the starting material. So if we now try to find out the starting material for this aldol condensation reaction, or if we try to find out P and Q, the P and Q must look like this. Either this formaldehyde will be P, or this compound will this aldehyde will be P, but P and Q must be this two. So P and Q will be like this. Now if we go forward again, if we go from the starting, so we will see that how this two reagent, that is this aldehyde, reacted with this aldehyde. So we have two CH3 group here in this aldehyde and a H which is connected with the carbonyl carbon like this in presence of a base, in presence of a, let me erase this thing to make it easier to understand now. In presence of a base, could be anything, I will just write base. Here it is K2CO3. So base will take this proton and the negative charge so formed will attack this carbonyl center, and the product we know that CH2 OH C CH3 CH3 and CH1. Which means our R. So R will be like this. We know this already. And this R will react with Cn minus, because it is written here that which upon treatment with Cn minus gives S. So Cn minus is a nucleophile. It will obviously attack the electrophilic center, which is the carbonyl carbon, and after the attack at carbonyl carbon, the carbonyl carbon will be converted to a hydroxide group, or this C double bond O will be converted to a COH or CHOH group. Now we have this attached with a nitrile group here, and this nitrile group upon treatment with acid and in presence of heat will first get converted to this carboxylic acid group, and under the same condition, that means H plus and heat, this carboxylic acid group will undergo an intramolecular esterification reaction to give you the final product, and this final product is also matching with the compound or with the structure given in our question. Now let us solve the three problems. So the first problem is the compound P and Q respectively are. So we know what is P and Q. P and Q are these two compounds, this one, this aldehyde, and this aldehyde. So let us check that which of the option is matching with our predicted product. So if we check the options, you can see that option A, no, not option A, sorry, option B is matching with our predicted product. So option B must be the correct one. Now if you go to our next problem, that means how does the compound R look like, then again let us go back here. our R is something like this. So one OH group connected with a CH2 and CH3, then a CHO. So here, so this one, if you check again this structure, that is structure number A or option number A, this is matching with our predicted R. So R will be this one. So this one, this option A is the correct option. So 2 problems solved. So now the next problem is, what is compound S? Now compound S, now if you go back again to our predicted products, this is compound S, where this nitrile group is attached to a hydroxide group containing carbon, and that carbon is also attached to a carbon which has 2 methyl group and a CH2OH group. So now among, we have to check the options. So option D, if we check option D, you can see that CN group is attached to a carbon containing a hydroxide group, and that carbon is again containing 2 CH3 and a CH2OH group. So option D is the correct one. So now from the solution of one problem, we have answered 3 questions. In our next problem, 2 different columns are given. In column 1, we can see various different reactions are given, and in column 2, the type of those reactions are written, and sometimes some product of that reaction or some intermediate is also mentioned. So we have to basically match column 1 with column 2. It may happen that one option of column A can be matched with more than one option of column 2. So we have to check the mechanism thoroughly. So if we go to column A first, column 1 and option A first, we will see that it is a diazonium salt which is reacting with a phenol, and a diazo coupling product is formed. So it is of course a coupling reaction. That means A is matching with S, of course, and here we can see that in this step, this hydrogen is getting replaced. This CH bond is actually getting replaced by a CN bond. So it is also a substitution reaction. So we can write S and R is matching with our first reaction. In reaction B, we can say that this diol is actually reacting in presence of an acid to form a carbocation, and after that, that carbocation is rearranging itself by a migration of methyl group, and a ketone is formed. But as there is a carbocation involved, so we can match this B of column 1 with T. T is the carbocation intermediate. Now if we go to our reaction number C, okay, so this is a reaction where a reduction is happening and a ketone is getting reduced. What is happening here? H minus is actually attacking this carbonyl center. So this is an addition reaction, of course, because H is getting added to this carbon center, and this carbonyl carbon has 2 planes, and as I have drawn here a very deep or a bold arrow here where the hydride is attacking from over the plane of this paper, and this thinner arrow is showing that the hydride may also attack from the below of the plane of paper. That means it may give 2 different kind of enantiomer in 50% yield, which means a racemization or a racemic mixture. So this reaction is basically an addition reaction which is giving a racemized product. So if we go to one slide back, yes, and if we check, we can see that this C can be matched with Q, which is an addition reaction, and also giving a mixture, a racemic mixture. So Q and P will be the correct option of column 2, which is matching with C. Now D is something which is a kind of substitution only reaction. So if we check the mechanism, what is happening here, in presence of the base, the thiol is getting deprotonated and then intramolecular substitution. That means this S minus is attacking the leaving group bearing carbon center here, and Cl minus is going away as a good leaving group, forming this compound. So this is a substitution reaction. So this D can be matched with the substitution, that means R here. So these are our options. So A matched with S and R, B with T, C with Q and P, and D with R. If you have liked my video, please click the thumbs up button as well as share the link with other people. And for more videos, please subscribe my channel and press the bell icon. Most importantly, please comment below about your needs related to chemistry so that I can make more videos on several other topics.